Most of your gas furnaces today have an induced draft motor, and they come in all kinds of shapes and sizes, but when you're working on a furnace, you need to understand how they operate and keep them operating properly. So the inducer motor on a gas furnace has two purposes. Number one, when the flame is established in the primary heat exchanger, the inducer motor draws the flame and the products of combustion into the primary heat exchanger and directs them through the channels of the heat exchanger. When it exits the primary heat exchanger, the induced motor then draws it through the secondary heat exchanger, where more heat is extracted from the products of combustion. Then the inducer motor exits the flue gases out through the vent. You'll also notice that most of your inducers have an inner tube and an outer tube. The inner tube is directing the vent gases into the vent to the outside, while the inner tube collects the moisture or the condensation that is made by the secondary heat exchanger and directs it to the condensate trap. So the inducer motor is generally attached to a plastic blower housing that is designed to channel the vent gases into the vent and the condensate into the condensate trap. This inducer housing is mounted onto the collector box or the front plate of the furnace, and this front plate is also designed to direct the vent gases into the induced draft motor to exit the furnace, and also to direct the condensate to the condensate trap to be deposited outside the furnace. One of the main misconceptions that technicians have about 90% condensing furnaces is that the furnace is not able to handle the condensate that is coming back into it from the vent. We have stated in various videos before that there are kits that are available from major manufacturers to take the condensate out of the vent pipe before it gets into the furnace. Make sure that the kit that you're using to do that is certified and approved by the major manufacturer of the furnace that you're installing. If not, there could be some real liability issues with carbon monoxide poisoning possibilities. So always consult the installation guide for the furnace that you're installing, and make sure that you install the vent and the condensate trap according to the manufacturer's specifications. Another point in the installation guide that many technicians overlook is to make sure that you level the furnace or slant it towards the front according to manufacturer specifications. In this particular example, on a upflow or downflow installation, you can go level to a ½ inch towards the front of the furnace, and on a horizontal application, you can go a minimum of 1/4 inch to a ½ inch maximum. If you do not follow these guidelines, condensation can collect at the rear end of the secondary heat exchanger, leading to furnace malfunction and probably secondary heat exchanger premature failure. When running the vent pipe to the outside, you need to make sure that you properly support the PVC venting as you run it through to the outside. Also make sure that you are sloping the vent back towards the furnace at least 1/4 inch per foot according to manufacturer specifications. The sequence of operation for most gas furnaces is that the induced draft motor starts up first, and then when it gets up to speed, it will close the pressure switch that is monitoring the vent. When the pressure switch closes, then the ignition cycle will start and the burners will light. If anything happens to the inducer motor or anything blocks the vent during the operation of the furnace, this pressure switch will open up and will shut down the furnace. When doing regular maintenance on a gas furnace, the bearings of the inducer motor need to be checked. Inducer motor bearings are subjected to very high temperatures over long periods of time. The bearings of an inducer motor are usually the first failure to occur in these motors. So your inducer motors can be different voltages, 115 volts or a 24 volt motor. In this particular wiring schematic, you have a wire coming off L2 to the common and off L1 to the high and the low. And you notice from this diagram that the supply voltage is 115 volts. And so this would be a motor on a two-stage gas furnace, which would run in high and low speed. This could also be a 24-volt circuit, which a lot of your furnaces today run the inducer motor on 24 volts. A lot of your top-end gas furnaces today run inducer motors with ECM motors. And these motors, of course, have high voltage that is powering the electronics in the motor with L1, L2 with high voltage. And then you have various wires, depending on the ECM motor, that send communication to the inducer motor from the control board to run at different speeds for different modes of operation. Some of your inducer ECM motors also have a feedback line. In this particular example, you have a pulse width modulation line, which sends the signal from the control board to the inducer motor to run at a particular speed. And then you have wires that send a signal back to the control board, which are RPM feedback lines that tell the board that the motor is at the speed that it was commanded to. So in order to properly troubleshoot these furnace motors, you would need to have the manufacturer's troubleshooting guide that would give you these voltages that you should see for the proper operation of the inducer motor.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.